Whenever we started talking about factoring, we briefly mentioned a special pattern, a difference of two squares, and some of you remembered that and some of you didn't, and I told you it wasn't a big deal. If you didn't, you could always group it. One of those other special patterns that was really, really important was called a perfect square trinomial. Do y'all remember learning about perfect square trinomial? Okay. Perfect square trinomial. Trinomial means it has how many pieces? 3. Okay. And so at the top of your sheet, I have a perfect square trinomial defined for you here. And what that means is, I've got this trinomial, and let me think of one that's going to work. Let's say x squared okay. So there are some criteria. There are 3 criteria that make this a perfect square trinomial. Okay, and those are listed on your sheet also. The first term has to be a perfect square. Perfect square. The last term has to be a perfect square. Okay. That's one criteria. The first and last terms have to be perfect squares. This is not, I don't know how I missed this one on there, but you might want to write it in. The second sign must be plus. It doesn't work if, now the first sign can be anything, but the second sign has to be plus. And here's where it gets confusing. The middle term has to be, if you take the square root of the first one, what's the square root of the first one? X. What's the square root of the last one? If you take the square root, multiply them together, and double them, you have to get what's in the middle. Okay? Square, square, multiply, and double. Okay? So you have to check off those 3 boxes to make sure it's a perfect square trinomial. And if it is a super easy factor. You don't have to put it all out and group it. You can just do the square root of the first. The first sign, if that was a minus, this would be a minus, okay? But because it's plus, we do first sign. The square root of the last squared.
Okay, you said, what got it?
All right, so you take the ends, the 2 ends, x squared and 36. What's the square root of x squared? And the square root of 36. If you put those together and double them, it has to be what sits in the middle. Well, right now, this is to factor. What we're going to do with completing the square is we're going to force them to be perfect square trinomials when they're not to start with. And I'm going to show you how to do it. Let me show you an example. You tell me yes or no, is it a perfect square trinomial? Actually, you want me to show you why this is? You want me to group it and show you that it works, or you believe me? Okay. Try it. You try it. Group it and see if it factors. X squared plus 12x plus 36. Factor that. Factor that the way you know to factor. What multiplies to 36 but adds to 12? So factor it and see what happens. You don't have to. Well, you remember how this works. You remember perfect square trinomials. That's okay. Which is the same thing as what? Okay. It's just a shortcut. It's basically what it is. It's a shortcut for factoring. And it's a nice, easy shortcut. Now, let me show you a couple. You tell me if they're... I'll give you a second to copy that. Some of them are still copying. Yes or no? perfect square trinomial or nah? I hear yes. I hear no. Let's see.
Perfect square.
Are the ends perfect squares?
Yes.
Yeah? Is the second sign a plus? Is the middle the product, double the product of the square roots of the ends? That's a mouthful. What's the square root here? What's the square root? Multiplied together gives you, and doubled gives you. So is it a perfect square trinomial? Yes.
How was it perfect? Like, it wouldn't matter if that sign is bigger or positive.
No, because here's what it's going to impact. When you do factor it, it's the square root of the first sign, square root of the last squared. It's factored. Now, wasn't that easier than grouping, though? So if you'd grouped, you'd had 4 times 25, which is 100. You'd found 2 factors of 100 that add to 20. And then you'd also have a negative in there. Okay? All right, everybody okay on that so far? What's wrong, Olivia? Yep, it's always whatever this first sign is, that's what goes in the middle. Second one has to be plus.
What if it's not plus?
It's not a perfect square trinomial. Okay. All right, so this is convenient because, and some of your homework is going to look like this. If I have something that looks like this, and I need to solve that for x, I could move the 9 over, make it equal 0, and factor and solve it, right? But what do you notice about the trinomial that's here now? It's a perfect square trinomial, right? How do you know it's a perfect square trinomial?
Square right there. Square.
Perfect squares. Plus on the second. X times 4 doubled is 8x. How does it factor? Factor it. X plus 4. Why is that convenient for me? How can I solve it now?
Well, I mean, you could square both of them.
That's exactly right. I could square root both of them. How do you know you can do that?
Because it's a perfect square.
Even if it wasn't a perfect square, though.
Because, I mean, that's to the second power. So,
What did we talk about whenever we were solving? If you only see x one time,
oh, you can square it.
you can SAD map your way out of it, right? So SAD mapping here would give me square root. X, what does x plus 4 equal?
3.
That's half the answer.
Plus or minus.
So now I know that x plus 4 is 3. This is number 1 on your homework, by the way. Or x plus 4 is negative 3. And now I can solve each one for x, right? Okay. So I get my 2 answers. This was nice because the way it was set up for me, I already had a perfect square there, right? Do we see that? Or a perfect square trinomial. It started me out with a perfect square trinomial. I didn't have to do anything. So what we're going to do is it's going to start us out with some things that are not perfect square trinomials, and we're going to find the value of a number that will make it a perfect square trinomial so that we can do this. Does that make sense? All right, so that's what your steps are for that you see. All right, so the first thing we need to look at is how to find a value. We'll have an x squared and we'll have an x. Let's say, we'll just start easy. Let's say I have x squared plus 8x. We're going to think backwards here. We know that second sign's got to be a plus, right? How could I figure out what needs to go in the blank to make this a perfect square trinomial? So now you got to think about those requirements kind of backwards. You're exactly right. Oh, no, you're not right. Why? Okay, so go back. Give me a way I can generalize this, that I could always, no matter what that value was, I could always find. Yeah. That's the first part of it. You're exactly right. This is the b, so I'm going to divide it by 2, as Robert said. That's exactly right. That'd give me 4. It's not, you need to square it.
No, I won't fire it.
All right. This is what I call the good C. Okay? Why is it good? It's good because it makes it a perfect square trinomial. Okay? So here, my b is 8. So if I do 8 divided by 2 and square it, I get, that's the value, that's my magic number that makes it a perfect square trinomial. How does it factor then? It'd be the square root of the first, that first sign, and then what? That's exactly right, 4. That's a great question. You don't want to complete the square if there is a number in front of x squared, so we'll divide it out if we see that happen. Una más. Let's make it harder. Why not? What do I need to put in the blank to make that a perfect square trinomial? Why is this one harder? It's an odd number in the middle, right?
Put it 9.
If I put a 9. If you have a 9, then x times 3 is 3x. Doubles would be 6x, not 3x. It would be a fraction. Think about the formula we came up with, right, Jerome? So my good C is going to be take the middle, divide it by 2, and square the whole thing. Now when I square a fraction, what happens? I square the top and the bottom, right? So I get 9/4. How'd I get that? Take the middle, divide it in half, and then square it. And that square goes top and bottom. All right, now let's pull everything together. Y'all ready? Let's actually complete the square. You know how to find the value that completes it. Now let's complete and solve. Here's where we're going to get into our steps. There's an example along the right side. I'm going to work through that example. If you want to write it because it helps you, go right ahead. All right, so my first step is I do these. Now the first thing I want to do is I want to look at it. And I want to say, because the directions say solve by completing the square. Well, as I look at it, I go, well, I can't solve by completing the square. Why? The square's not complete. It's not a perfect square trinomial. So, take a 3 out of all of them first. If you ever see a leading coefficient when you complete the square, you have to get rid of it. You cannot complete the square with a number in front. And Jada, that addresses that question that you asked. All right, so I'm going to divide everybody by 3. Everybody. Even the 0. So I get x squared minus 10x plus 9 equals 0. Well, so my question now is it a perfect square trinomial now? No. And it's tricky because, look, the ends are perfect squares. The second sign is a plus, but where does it fail to meet the criteria? That middle term, right? All right. So does everyone agree that this is the number that's making it not a perfect square trinomial? Okay? I call that a bad C. It's bad because it does not make it a perfect square trinomial. If it's bad, I don't want it over there. I want to move it. Okay? Like my neighbors, I wish they would move. That is correct. All right. My neighbors, let me clarify in case my neighbors are watching this video. I have nice neighbors on 2 sides. It's just one side. Okay. Now I have a hole here on the end, right? I'm going to put my blank here so I keep track. That's where I want to put my good C when I find it. And then on the right side, I've got -9, but I'm going to do a plus blank here too, and this is why. If I go in and I add a value here, because this is an equation this time, I got to keep it balanced. That's exactly right. I got to do whatever I do to one side, I got to do to the other. Am I talking too fast? Y'all staying with me? Y'all okay? All right. So find the good C. Whoa there. 25. You're exactly right. Take the B. And the sign doesn't matter on this because when you square it, it's going to be positive. So 10/2 squared, right? Right. Whenever you, it'll still equal 25 because when you square a negative, it becomes positive. Huh? Yep. We're going to put 25 in both places. Okay. We're going to put it here. And we're going to put it here. Is anybody confused? Now this becomes a problem just like that very first problem we worked. Look at this side. It's a what? Perfect square trinomial. Factor it. What's it look like factored?
X minus 5.
Uh-huh. Squared. What's the other side look like?
16.
Can you solve this now easily?
Yeah.
What do you do?
Square root.
Square root. Now split it up, right? Because I got a whole number there. So x minus 5 equals 4. X minus 5 equals -4. 9 and what? 9 and 1. Pretty easy? Yeah. Do you remember how to do it now? Do you remember doing this or no?
Yeah.
You could, depending on who you had, they could have skipped over it. Sometimes it can be a little tough. Some teachers skip over it. I don't like to skip over it because I think it's a good method. Oh, is it? All right, let's do one more example together. I'll do this one off your homework. Let's do this one. Usually they get harder as you go, so this is the last one in your... So the directions for this say, solve the equation by completing the square. What is the very first thing that I need to do? Take out that 6, right? I cannot have a leading coefficient when I go to complete the square. Now, all of them that you go to complete the square on won't have a leading coefficient. This one just does. What does it leave me with? A squared minus what? 2x. That's right. So Chandler said that minus is throwing it off right from the beginning. That's correct. It also, 3 is not a perfect square. I mean, it's just wrong all the way around, right? There's no way that's going to work. Yeah. That's exactly right. Good job, Jerome. That's right.
And then that number on the thing, 4, no.
All right, wait. They said wait just a second. You're getting ahead of them.
You gotta do 2 over 2 squared.
So what is it? That's right. You put it over, You put it over 2 and you square it to get 1. Good job. You're in the home stretch now. You found the good C. Now it's an easy factor, right?
Yeah.
How do you factor it?
X plus,
Close. X minus 1. Remember to keep that, guys. Equals 4. Good job, y'all. I'm impressed. Well, no, it's not that I didn't think you could do it. It's just that normally it's a little bit of a difficult concept.
Harder than that on the
That's the hardest.